Hi students, today we are going to see about law of conservation of energy. When an object is thrown upwards, its kinetic energy goes on decreasing and consequently its potential energy keeps increasing, neglecting our resistance. When it reaches the highest point, its energy is completely potential. It means the kinetic energy becomes zero. The potential energy is only the energy is potential. Similarly, when the object falls back from a height, its kinetic energy increases whereas its potential energy decreases. When it touches the ground, its energy is completely kinetic. At the intermediate points, the energy is both kinetic and potential. When the body reaches the ground, the kinetic energy is completely dissipated into some other form of energy like sound, heat, light, and deformation of the body, etc. In this example, the energy transformation takes place at every point. The sum of kinetic energy and potential. So the total energy is conserved. This is state as the law of conservation of energy. Okay, what is the law of conservation of energy? This is a 2 mark. The sum of kinetic energy and potential energy, that means the total mechanical energy always remains constant. The total energy is conserved. This is the law of conservation of energy. Mark it. It is a 2 mark question. So at a height h, the object is at a height h at a point A. Okay, then U equal to mgh. So kinetic energy becomes 0. E equal to U. Energy, total energy becomes potential energy. And the object reached at the point B, U is not equal to 0 and kinetic energy is not equal to 0. So the total energy is equal to sum of the potential energy and kinetic energy. And H minus Y. Okay, it decreases. It goes on. What is that? Potential energy decreases. And it reaches the ground. U equal to 0. Potential energy becomes 0. Kinetic energy is not equal to 0. So the total energy is the kinetic energy. So law of conservation of energy states that energy can neither be created nor destroyed. It may be transferred from one form of energy to another form of energy, but the total energy of an isolated system remains constant. Mark it, this one. So the total energy is purely potential energy. Already I told you that is purely kinetic energy. But in the case B, the object comes to down and the distance is y. A to B is y. At the time, the potential energy is not equal to 0. Kinetic energy is not equal to 0. So total energy is sum of the potential energy and kinetic energy. And the object reach the ground at the point C. Potential energy becomes 0. Kinetic energy is not equal to 0. That means E is equal to Ke. U is equal to mgh. Okay, U is the potential energy, that is equal to mgh. Okay, do you understand this one? Next topic, we are going to discuss about power. Definition of power. Power is the measure of how fast or slow your work is done. So power is defined as the rate of work done or energy delivered. So symbol of power is P. Momentum also P, but it is a small p. Power is a capital P. Symbol, power of symbol. P is equal to work done W divided by time taken T. So P is equal to W divided by T. Average power is defined as the ratio of total work done to the total time taken. So you write average power, P average equal to instantaneous power is defined as the power delivered at an instant. That means as time interval approaches 0. So P instant equal to dW divided by dt. The next one is unit of power. Power is a scalar quantity. Its dimension is ml square t power minus 3. SI unit of power is watt, named after the inventor of the steam engine James Watt. 1 watt is defined as the power when 1 joule of work is done in 1 second. Okay, mark it. This is a 2 mark and units are 1 mark. Power unit, unit of power, and dimension of dimensional formula for power. These are all 1 word question, and define watt is a 2 mark question. What is the what? The power when 1 joule of work is done in 1 second, that is 1 W equal to 1 joule second power minus 1 kilowatt. Higher units, kilowatt hour, megawatt, and gigawatt. So 1 kilowatt equal to 1000 watt, that is equal to 10 power 3 watt. 1 megawatt equal to 10 power 6 watt. 1 gigawatt equal to 10 power 9 watt. Okay, you write the unit of the scientist unit. You write a small letter. Watt, Newton. These are all full name. You write that is in the small letter, but symbol is write in a capital letter. For motors, engines, horsepower. Okay, horsepower into watt. 1 HP equal to 746 watt. All electrical goods come with a definite power rating in watt printed on them. A 100 watt bulb consumes 100 joule of electrical energy in 1 second. The energy consumed in joule in terms of power in watt, and time in second is written as 1 joule equal to 1 watt second. When electrical appliances are put in use for long hours, they consume a large amount of energy. Okay, so watt second, small unit is a watt second. Okay. So in the case electrical energy, we measured in the unit kilowatt hour. So electrical unit 1 kilowatt hour equal to 1 into 10 power 3 watt into 3600 second. So 1 electrical unit equal to 3600 into 10 power 3 watt second. So 1 electrical unit equal to 3.6 into 10 power 6 joule, because 1 joule equal to 1 watt second. So 1 kilowatt hour equal to 3.6 into 10 power 6 joule. So electricity bills are generated in units of kilowatt hour for electrical energy consumptions. 1 unit of electrical energy is 1 kilowatt hour. Okay, kilowatt hour is unit of energy and not of power. Okay, do you understand this one? Dr vector, that is W equal to integral F vector dot dr vector. So W is equal to integral dW, that is equal to integral dW divided by dt into dt. So multiply and divide by dt. So you get dW by dt into dt. Okay. Then velocity v vector equal to dr vector divided by dt. So you write dr vector equal to v vector into dt. Okay. So in the case f vector integral f vector dot dr vector equal to, you multiply and divide by dt. So you get f integral f vector dot dr vector divided by dt into dt. You already know what is that. Dr vector divided by dt is v vector. So integral f vector dot v vector into dt. Okay. So you write integral dw by dt, because this f vector d vector equal to f vector, integral f vector d vector equal to w, and w equal to integral w dt into dt. So you equate these two equations, that is f integral dw by dt into dt equal to integral f vector dot v vector into dt. Okay. So you take it left hand side, take it sorry, right hand side, take it left hand side. So integral, what is that in the case, this one, w divided by dt into dt minus integral f vector dot v vector into dt. Okay. So that is equal to 0. That is equal to 0. Okay. So take it outside, dt and integral dw divided by dt minus f vector dot v vector into dt, that is equal to 0. Okay. So the bracket of integral dt goes to right hand side, so it becomes 0. So dw divided by dt minus f vector dot v vector equal to 0, or dw divided by dt equal to f vector dot v vector. So p is equal to f vector dot v vector. Okay, this is a relation between power and velocity. I hope you to understand this one. This is a 3-mark question. Okay, next topic is a collisions. Collision is a common phenomena that happens around us every now and then. For example, carom, billiards, marbles, etc. Okay, collisions can happen between two bodies with or without physical contacts. Linear momentum is conserved in all collision process. When two bodies collide, the mutual impulsive forces acting between them during the collision time. So delta t, that collision time is a small time. So you take a delta t, produces a change in their respective momenta. That is, the first body exerts a force F12 vector on the second body. From Newton's third law, what is that? Every reaction equal to equal and opposite reaction. So the second body exerts a force F21 vector on the first body. This causes a change in momentum delta P1 vector and delta P2 vector of the first body and second body respectively. So you write momentum, change in momentum delta P1 vector equal to F12 vector delta T and delta P2 vector equal to F21 vector delta T. Okay, add these two equations. Delta P1 vector plus delta P2 vector equal to F12 vector delta T plus F21 vector delta T. So the common delta T is common. Take it outside of this equation. So F12 vector plus F21 vector into delta T. You already know what is the Newton's third law, that is 1 2 vector equal to minus F21 vector. So substitute the value of this equation, the above equation, you get the left side equation become 0. So delta P1 vector plus delta P2 vector equal to 0. Delta is common of this equation. So take it outside. Delta into P1 vector plus P2 vector equal to 0. Then dividing both sides by delta t. So taking the limit delta t tends to 0, we get limitation delta t tends to 0, delta P1 vector plus P2 vector divided by delta t, that is equal to d into P1 vector plus P2 vector divided linear momentum is conserved quantity. So the momentum is a vector quantity. Vector addition has to be followed to find the total momentum of the individual bodies in collisions. Okay, do you understand this one? The next one is the types of collisions. Okay, the collision have two types, that is elastic collisions and inelastic collisions. Okay, so the total energy in the collision process and the total linear momentum and total energy are always conserved, whereas the total kinetic energy may not be conserved always. Some part of initial kinetic energy is transformed to another forms of energy. Okay, this is because the impact of collision and deformation occurring due to collision may in general produce heat, sound, light, etc. by taking these effects into account. So, two types, that is elastic collisions and inelastic collision. So, what is the elastic collisions? That is, the total initial kinetic energy of bodies before collision is equal to total kinetic energy of the bodies after collisions. Okay, this is elastic collision. So you write total kinetic energy before collision equal to total kinetic energy after collision. This is the elastic collisions. Mark it. This is a 2 mark. Then in elastic collision, in a collision, the total kinetic energy of a bodies is not equal to total final kinetic energy of the body, that means after collision. Okay, is not equal to, so total kinetic energy of before collision is not equal to total kinetic energy after collision. Okay, so you rearrange this equation, that is total kinetic energy after collision minus total kinetic energy before collision. So that is equal to loss in energy during collision. That is equal to that loss in energy is, you write delta Q. Okay, even though kinetic energy is not conserved, but the total energy is conserved. This is because the total energy contains the kinetic energy term and also a term delta Q, which in energy during collision is transformed to another form of energy like sound, thermal, etc. Further, if the two colliding bodies stick together after collision, such collisions are known as completely inelastic collisions or perfectly inelastic collision. Such a collision is found very often. For example, when a day putty, when a clay putty is thrown on a moving vehicle, the clay putty or bubble gum, okay, sticks to the moving vehicle and they move together with the same velocity. Okay, do you understand this one? And the comparison between difference between elastic and inelastic collision. This is a 2 mark question or 3 mark it. Elastic collision, in the case of elastic collision, total momentum is conserved. In elastic, total momentum is conserved. Total kinetic energy is conserved in elastic collision. In elastic collision, total kinetic energy is not conserved. in elastic collision, forces involved are conservative forces, but in the case of inelastic collision, forces involved are non-conservative forces. And elastic collision is mechanical energy is not dissipated, but in the case of inelastic collision, mechanical energy is dissipated, light, sound, etc. Okay, do you understand this one? And next topic is elastic collisions in one dimension. Mass is m1, the first body mass is m1 and its initial velocity is u1, and second body is m2 and its velocity, second body velocity is u2. Okay, it moving a straight line in a positive x-axis and on a frictionless horizontal surface. It move a frictionless horizontal surfaces. Okay, so after colliding the body, this is a before collision. After colliding the body, after collision, the body move the same positive x direction. The m1 have velocity v1 and m2 have velocity is v2. Okay, so this m1 moves faster than the mass m2, that is u1 is greater than u2. For elastic collision, the total linear momentum and kinetic energies of the two bodies before and after collision must remains the same. So, write momentum of mass. First body before collision is m momentum before collision, momentum of body, first body is pi1 equal to m1u1, and after collision of first body is pf1 equal to m1v1, and momentum of the second body is p before collision, that is pi2 equal to m2u2, and after collision for bodies before collision is pi equal to pi1 plus pi2, so pi is equal to mu1 plus mu2. Okay, then the after collision the total linear momentum is pf equal to pf1 plus pf2, so pf equal to p1 v1 plus m2 v2. Okay, then from the law of conservation of linear momentum, total momentum before collision pi equal to total momentum after collision pf. So you write this equation. pi you already know what is that, m1 u1 plus m2 u2, and pf equal to m1 v1 plus m2 v2. So take it m1 one side and m2 the other side. Okay, so you write this one. That is m1 u1 minus m1 v1 equal to m1 v1 m2 v2 minus m2 u2. Okay, so take it, m1 is constant, common both term in left hand side, so take it outside, m1 into u1 minus v1, then m2 into v2 minus u2. Okay, and then after collision, first body, that is m1, and first body of kinetic energy before collision is ke I1, that is equal to of m1 u1 square, and after collision of first body kinetic energy of first body Ke F1 equal to of m1 v1 square, and Ke2 equal to before collision of second body, kinetic energy of second body Ke I2 equal to of m2 u2 square, and after collision of second body of kinetic energy is Ke F2 equal to of m2 v2 square, and total kinetic energy of the system is Ke equal to Ke, that is before collision is Kei equal to Ki1 plus Ki2, Kei2. So Kei equal to of m1 u1 square plus of m2 u2 square. Okay, then after collision of kinetic energy, total kinetic energy is Ke F equal to Ke F1 plus Ke F2. So Ke F equal to of m1 v1 square plus of m2 v2 square. Okay, after you already know what is that. For elastic collision, the total kinetic energy before collision equal to total kinetic energy after collision. So you write the equations for kinetic energy of m1 u1 square plus of m2 u2 square equal to of m1 v1 square plus of m2 u2 v2 square. Half is cancel. In this equation you get m1 u1 square so rearranging the equation the same this way. Okay, rearrange one half cancel, so m1 term take it left side, m2 term take it right side. So m1 u1 square minus v1 square equal to m2 v2 square minus u2 square. Okay, do you understand this one? This is the formula. What is that? A square minus b square equal to a plus b into a minus b. So you write, we use u1 square minus v1 square, you write in this way, m1 into u1 plus v1 into u1 minus v1, that is equal to m2 into v2 plus u2 into v2 minus u2. Okay, then dividing this equation, which equation? This one, this equation, divide by that equation. Okay, so m1 u1 plus v1 into u1 minus v1 divided by m1 into u1 minus v1, that is equal to m2 v1 plus u2 into v2 minus u2 divided by m2 v2 minus u2. Then the denominator v2 minus u2 and numerator v2 minus u2 cancel each other. So you get the u1 m1 cancel, m2 cancel, so you get u1 plus v1 equal to v2 plus u2. So u1 minus u2 equal to v2 minus v1. So then u1 minus u2 equal elastic head-on collision. The relative speed of the two elastic bodies after the collision has the same magnitude as before collision, but in opposite direction. Okay, so the result is independent of mass. Okay, then v1 and v2, you get v1 equal to v2 plus u2 minus u1, v2 equal to u1 plus v1 minus u2. Find the final velocities v1 and v2. So m1 into u1 minus v1 equal to m2 into, substitute the value of v1 in this equation. Which equation? That is in this equation. Okay, so m1 u1 minus v1 into m2 u1 plus v1 minus u2 minus u2 2 u2. Okay, so m1 u1 minus v1 equal to m2 into u1 plus v1 minus u2. Okay, elaborate this equation. That it means multiply m1 in left side, m2 in right side. m1 u1 minus m1 v1 equal to m2 u1 plus m2 v1 minus 2 m2 u2. Okay, so m1 u1 minus m2 u1 plus 2 m2 u2 equal to m1 v1 plus m2 v1. So m1 u1 is common in this term. Okay, in this term u1 is common, so take into v1. So you need v1 value. So v1 equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Okay, so in the case this is v1, and next we find v2 value. So substitute the v1 values in this above equation. Which equation? In this equation you substitute the v1 values and you calculate the result. v2 equal to 2 m1 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. Okay, do you understand this one? Up to this I hope you understand. And case 1, when bodies has the same mass as m1 equal to m2, so you m1 equal to m2, v1 equal to 0, v1 equal to 0 into u1 and 2m2 divided by 2m2 into u2. So u1 is 0, this term 0. Okay, so v1 equal to u2. 2m2 m2 cancel each other, so v1 equal to v2 and v2 equal to 2m1 by 2m1 divided by 2m1 into u1 plus 0 into u2. So 2m1 m1 cancel, so v2 equal to u1. Okay, two bodies of equal mass collide, and after the collisions their velocities are exchanged. Then next one is the case 2. What is that? When bodies have the same mass. In this case, you consider the mass is m1 equal to m2 equal to m1 equal to m2. Okay, the same in this case also. And second body called target is at rest. Sorry. Okay, u2 equal to 0. So m1 equal to u2 becomes 0, the initial velocity becomes 0, so v1 equal to 0, v2 equal to u1. Okay, the next one is case 3. The first body is very much lighter than the second body. That means m1 is very less than m2 and m1 by m2 is very less than 1. So the ratio m1 by m2 is not it is nearly equal to 0. Okay, so body is at rest, u2 equal to 0. So v1 equal to m2 by m1 minus 1 divided by m1 by m2 plus 1 plus 2 m1 2 divided by m1 divided by m2 plus 1. So you get 0 minus 1, which term is 0? v1 equal to 0 dividing numerator and denominator by the equation. Okay, so you get 2 m1 divided by m2 divided by m1 by m2 plus 1 into u1, 1 minus m1 by m2 divided by m1 m2 plus 1. So v2 equal to 0. So the opposite direction with the same initial velocity as it has negative sign. So in this equation, which one? That is v2 equal to 0 implies the second body, which is heavier in mass, continues to remain at rest even after collision. For example, if a ball is thrown at a fixed wall, the ball will bounce back from the wall with the same velocity with which it has thrown, but in opposite direction. Okay. The second body, another case number 4, the second body is very much lighter than the first body, so m2 is very less than m1, so m2 by m1 is very less than 1, then the ratio m2 by m1 equal to 0. m2 divided by m1 equal to 0. Okay, so the body is at rest, so u2 becomes 0. Dividing by equation 4.53, this equation 4.53. Okay, multiply and divide by m1. Okay, so the value is substituted, equations are divided by m1. So 1 minus m2 divided by m1, 1 plus m2 divided by m1 into u1 plus 2 m2 divided by m1, 1 plus m2 by m1. Okay, so you get v1 value is 1 minus 0 divided by 1 plus 0, and v1 equal to u1. Okay, so then v2 equal to multiply and divide by m1. Okay, v2 equal to 2 divided by 1 plus m2 divided by m1 into u1 plus m2 by m1 minus 1 divided by 1 plus m2 divided by m1. So you get v2 equal to 2 divided by 1 plus 0, that is into u1. So you get v2 equal to 2u1. Okay, so this equation implies that the first body, which is heavier, continues to move with the same initial velocity. So the equation suggests which equation? 6.2, that is v2 equal to 2u1. Okay, suggests that the second body, which is lighter, will move with twice the initial velocity of the first body. It means that the lighter body is thrown away from the